Hello everyone, let's start with our connective tissue lecture. Connective tissue, also known as fascia in some terminology in books. So that's your bone, cartilage, and regular connective tissue. So we have basically 9 topics to cover today. So let's jump into it. So first one is, what are the components of a connective tissue? So connective tissue is made up of cells and the extracellular material. We have a mnemonic for it, flip in MMA, like the MMA fight. So all these letters define all the different cell types. So flip in MMA. Extracellular matrix is like the cytoplasm. It's like the watery fluid where these cells will sit, and that is made up of the protein and ground substance. So the proteins are your collagen fibers, your reticular fibers, and elastic fibers, mostly found at the basement membrane. Your ground substance is your watery fluid, also known as a hyaluronic acid, proteoglycans, and glycosaminoglycans. Next is, what is a function of connective tissue? The function is to provide structure and metabolic support to the connective tissue cells. Then where is the origin of connective tissue? It's undifferentiated mesenchymal cells from the mesoderm origin. So these are basically stem cells which provide all the connective tissues. And the nuclei is basically not spindled, and cytoplasm is not stained. But there is a large euchromatin and large nucleoli, which signifies there's a high cell activity in these stem cells. So, like here, we have a picture. You just have to recognize these are your mesenchymal cells, your stem cells. They have these oval shape, almost spindle, and then has a large staining of euchromatin nucleoli, um, with very few fibers. So they're very spread out, nothing going on in between them. So they're basically baby cells floating around. Next, we go to the layers of extracellular matrix. Like we said, connective tissue is made up of cells and the extracellular matrix. The extracellular matrix are permanent, meaning they are always there, they always stay. So your ground substance and your protein fibers. So your ground substance, like we said earlier, was the hyaluronic acid, and protein fibers are your elastic, collagen, and reticular fibers. So all these elements are permanent, whereas cells, some are permanent, some are wandering. So we have a quick way of remembering all the M's, put it upside down, those are your wandering cells, and permanent AF. I hope I don't have to define AF with exclamation point. So your M, your mesenchyme, and your macrophages are wandering, whereas your adipocyte, AF, and fibroblast are permanent as F. Okay, so let's look at the picture. Once again, we have our extracellular matrix and our cells that make up connective tissue. Extracellular matrix is mostly always permanent. So you have your blood vessels, your watery hyaluronic acid, and you have 3 protein fibers, elastic, collagen, and reticular. Later on, we're going to define these with numbers, different collagen types. Then we have cells, like I said, the M's are wandering, some mesenchyme and macrophage wandering. AF are your permanent cells. So fat and your fibroblast are always there. Whereas your mesenchyme, your stem cells, and macrophages is like your trash truck that comes in every once in a week, and they just float around and pick all the dead cells. So recap real quick. We're talking about connective tissue, also known as fascia. It's made up of cells and extracellular matrix. Cells, remember, we have mnemonic, and then extracellular matrix are your collagen, reticular, elastic fibers, and then as well as your ground substance. Your function is to provide support and structure and metabolic support to all the other cells and organs. The origin is usually mesenchymal origin, which has large euchromatin and nucleoli. Your layers are your extracellular matrix that are permanent, and then cells that can be the M are wandering, and then the permanent AF. So let's jump into the different types of connective tissue cells. Like I said, it's FLIP in MMA. So FLIP, fibroblast, lymphocyte, eosinophil, plasma cell, neutrophil, macrophage, mast cell, and adipocyte. So what are fibroblasts? Fibroblasts make up your extracellular matrix and ground substance, mostly the hyaluronic acid, the watery substance. So you can think of fibroblast as an fiber cell, or the cell that provides the framework, the foundation. Lymphocytes are for immune. Eosinophils are for allergic reactions. Plasma cells are for antibodies and allergic reactions. Neutrophils, phagocyte bacteria. Similarly, macrophages phagocyte dead cells. They're also antigen presenting cells, so they present the antigen to the cell, which is very important in our allergic lecture. And then they also have growth factors. Mast cells are pharmacologically active. Mast cells release other mediators during allergy, for example, and adipocyte is your fat. Another mnemonic for side note is you have adipocyte that makes up the adipose tissue, and you have two types of adipose tissue. You have the WAT, which is your white adipose tissue, and you have your BAT, which is your brown adipose tissue. BAT is usually found in babies. So what one? Because it's one cell, one glob of fat, whereas BAT is balls of fat. So just remember that. So you have FLIP and MMA, those are your connective tissue cells, and then what one? BAT balls for fat. So we will just look at a few pictures. You have to start to differentiate different stains and different cells by looking at a picture of what cell it is. So for fibroblast and fibrocyte, here you can see fibroblast, pretty long spindle, fibrocyte, pretty skinny because it is quiet. So fibroblast is active, fibrocyte is quiet, it's hiding. Similarly here, you have the fibroblast, which is pretty long and big and thick, whereas its quiet partner is hiding in the background. Leukocytes, pretty round, oval shaped, and then collagen fibers are in between these cells. Okay, here is your macrophage. So macrophage usually has a pretty irregular structure because it has to do pinocytosis and phagocytosis. A lot of granules you will find around the structure. That is basically too acidic and to kill the product. And then finally here we have mast cells. Mast cells release all these products, heparin, histamines, cytokines, chemokines, leukotrienes. So here's your mast cell, similar to macrophage, has irregular structure, but a lot of granules that are around it. And these granules are the ones that are releasing all of the product. So release granules have a role in local inflammation, innate immunity, and tissue repair. So these are pretty important. So once again, here's mast cell. I would look up more images under Google and start differentiating mast cells and macrophages. Here's your macrophage, pretty big. Here are your fibroblasts and the quiet fibrocytes. Okay, going back. So that was your connective tissue cells. Once again, recap, your connective tissue is made up of cells and extracellular matrix. The function is to provide structure and metabolic support for cells. Usually origin is from mesenchyme origin, mesoderm. The layers, once again, cells, you have wandering and permanent cells. An extracellular matrix is made up of the ground substance and the collagen, elastic, and reticular fibers. The cells are FLIP in MMA, fibroblast, lymphocyte, eosinophil, plasma, neutrophil, macrophage, mast cells, adipocytes, and the most usually do either phagocytosis or are used in allergic reaction or allergic mechanisms. Then we have another monocytes. So besides macrophages, so monocytes are the precursor that make up macrophage. Then we have another mnemonic here, M3 cold. I don't know if you guys know BMW M3, it's a car, so M3 is cold or M3 cold. So here's your 3Ms, monocyte, macrophage, microglia, cold, Kupffer, osteoclast, Langer, dendritic. So monocytes, they're precursor, they make the macrophage in blood. You find them in the blood. Macrophages, this is a connective tissue that releases, like we said earlier, cytokines, antigen-presenting cells, and growth factors. And they look like these, pretty fat, ugly, no structure. Microglia are like macrophages, but they are macrophages for the brain and central nervous system. Kupffer cells are macrophages found in the liver. Osteoclast, clast is breakdown, so it breaks down the bone. Langerhans cells are antigen-presenting cells like macrophages, but in the epidermis, whereas dendritic cells are found mostly in the lymph. And we will learn a lot about dendritic cells in the allergic portion. Then we come into those connective tissue or protein fibers that you find in the ground substance. So connective tissue fibers are collagen, reticular, and elastic. So you just have to remember collagen is your collagen 1, 2, 3, and 7. Reticular is 4, and then elastic comes from elastin. So collagen fibers, just remember the numbers 1, 2, 3, 7, or I think I remembered it as 1723 or 1732, whatever you want. 1, 2, 3, 7, and reticular number 4. Reticular, usually you find it in the bone marrow, spleen, lymph. It provides organ framework, and it's produced by reticular cells, which are modified fibroblasts. Forms reticulum and uses a silver stain. We call it ergophilic, and that is for reticular fibers. Elastic fibers, usually elastic meaning flimsy and flexible, find it in the arteries. It's able to bend and stretch, formed by elastin and fibrillin, secreted by fibroblast and smooth muscles. So here we have reticular cells, like we said. Reticular cells, call it number 4. Found usually in bone marrow, spleen. So these are the reticular fibers of the lymph node. And they're messy, they're all over the place. As you can see, there's no structure to these guys. And then it's usually common in the hemopoietic tissue and lymph organs, bone marrow, spleen, lymph nodes, whereas our elastic is usually found in arteries. So here is your fibrillin microfibrils, pretty crazy, all over the place, very numerous. Whereas your elastin that comes from fibroblast is a scaffold of microfibrils, and it's pretty dense dots that are formed. And this elastin that accumulates will form this big ball. That is your elastic fiber. Once again, this is how the elastic fiber is formed. So you have these microfibrils or fibrillin, that is your scaffold or your framework, and it is a mesh that is a cylinder. So in the cylindrical microfibril or fibrillin mesh, you will get this fill-in. Basically, it's like pushing in jelly or glue into a cylindrical bottle, and that jelly is your elastin. That will give your flexibility. So all of the blue in between is your elastin. And then it goes throughout the whole length. Microfibril or fibrillin just holds it together as a framework, or we call it a scaffold. Then we use these collagen fibers and make collagen. So collagen, there's three types. You have the fibril collagen, the sheet collagen, and the anchoring collagen. So fibril is collagen 1, 2, and 3. Sheet is 4. I remember it as there is a sheet, has 4 corners. So there's 4 corners to a sheet. Fibril, so just remember fibril has to be the other 1, 2, and 3. And then anchoring is 7. So it looks like an anchor. Right, 7, anchor. So here's your fibril 1, 2, 3, sheet 4, and anchor is 7. Anchor basically anchors a basal lamina, which is your collagen 4, to the reticular lamina in the basement membrane. That is a pretty important concept because you have epithelial on top and you have few layers going on in the basement membrane and you have connective tissue underneath it. Then we go to the collagen numbers. So we have collagen 1, collagen 3. Remember, just be careful, these numbers are not 1, 2, 3. These are 1, 3, 2, 4. I don't know why. So collagen 1 is all your periodontium structures. So basically it can be your PDL, pulp, cement, dentin, gingiva, skin, and bone. Collagen 3 also has your PDL and pulp, but also comprises your bone and your vessels. So this one is mostly your vessel structures, not as hard. 2 is your cartilage, and 4 is your basement membrane. Once again, basement membrane, like we said, is the fourth, collagen 4, and it comprises of lamina lucida and lamina densa, and connects it to the reticular, which is 7, collagen 7. And then lastly, a pretty important concept of side note, metal metallic proteases, they cause oral diseases such as inflammation of the periodontium, periodontitis, or inflammation around an implant, so peri-implantitis. And they induce tissue destruction and start to dissolve that extracellular matrix, so all the cells and the fibers and the collagens that we just talked about. So once again, another picture that is pretty good to burn in your memory. So here you have your collagens, 1, 3, 2, 4. Like I said, 1 is usually most of the periodontium. 3 is also PDL pulp, but mostly the vessels. 2 is the cartilage, and 4 is your basal and reticular lamina. And once again, matrix metallic proteinases, they cause oral diseases because they start breaking down the extracellular matrix. So I hope this is a good image for you guys to remember. Then we will go do another recap. So we just did connective tissue made up of cells, extracellular matrix. The function is structure and metabolic. They come from mesenchyme mesoderm cells, which have large euchromatin and nucleoli because they're stem cells and they have a lot of high nuclear activity. Then we have our cells of connective tissue, which is flip in MMA. Also have monocyte cells, which is M3 cold. Then we have 3 types of connective tissue fibers that make up 3 types of collagen. And then you have collagen that is found in the oral cavity, which is 1, 3, 2, 4. 1 is periodontium, 3 is your PDL pulp and vessels, 2 is your cartilage, and 4 is your basement membrane, which is made up of basal lamina and reticular lamina. And lastly, MMPs cause oral diseases like periodontitis and peri-implantitis. Finally, we go to the type, put them all together and discuss what are the type of connective tissues. So there's loose connective tissue, a dense connective tissue, and then dense has other subcategory, dense irregular and dense regular. So loose connective tissue usually find is the lamina propria or the pulp. Loose meaning no stress, it's chilling, loose collagen, made up of elastic reticular fibers and a lot of cells. So they're loose. Dense irregular, you find it in the dermis, whereas dense regular, the strongest, you find it in the tendon and ligaments. Dense irregular is more stress resistant, tight collagen. Dense regular is more stress resistant and has longer collagen. And then we just have distinction between the cells. And then here's our example of our dense irregular connective tissue. Start recognizing that there's fewer cells, tight collagen, and fewer fibers in between the cells. And then I had another picture for dense regular. I will upload that later. Then we go into, lastly, the two types of adipose tissue. Adipose tissue, you have your white or your yellow fat, and you have your brown, which is brown fat. Like we said earlier, white is what one meaning white as one unilocular, one ball of fat, whereas brown is pockets of fat, and they're multi. White is usually found in adults and it accounts for 20% of the body weight. Females usually have more of white fat than male, whereas brown fat, you usually find it in babies. It's good if you have it as an adult because it has a lot of mitochondria and leads to fat burner. Whereas our white fat, like we know of the fat that we're used to, that stores triglycerol at about 9.3 kilocal per gram, and also is an endocrine organ releasing hormones. And then finally, we will discuss the cells again, all of the cells of connective tissue in a small detail in a chart, so it's easier to organize. So here we have fibroblasts. So the first we have our flip. Write that again. I like it. Flip N M M A. So in our flip we have our fibroblast, and fibroblasts comes from mesenchymal origin. They are long cells with spindle nucleus and collagen process. The function is for one of the function, and another topic is that during wound healing, these fibroblasts will become myofibroblasts. And then there is another side topic is that the fibrocyte is a is inactive fibroblast, and myofibroblast is during wound healing triggered by growth factors. Then you have lymphocytes, don't know much about those in this lecture. You have eosinophils and other leukocytes. And leukocytes mostly migrate through the capillaries or diapedesis. They have a lot of red granules in histology slides. Eosinophils, red granules. So think blood increases vascular permeability, so causes edema, redness, pain during inflammation. Then there is plasma cells, usually come from B lymphocytes. They also have a round basophilic cytoplasm, rich in rough endoplasmic reticulum, and the most common distinction is they have a clock face. So I'll show you here. So they look like clocks right here, and you can see they have some type of shape. So if you see some type of a clock shape, that means it is a plasma cell. Then we have macrophages. Macrophages, like we said earlier, come from monocytes. They have euchromatin nucleolus, irregular cell, and used to eat up other stuff by pino or phagocytosis. Lastly, we have mast cells. Mast cells are usually found near blood vessels because they have to be quick to respond during allergic reaction. They have a lot of granules, a lot of material to release mediators like histamine, heparin, cytokines. They have an oval shape, and they are metachromatic, meaning different colors because of high acidity. So here are your mast cells with different granule shapes going on. You can see in the purple, then has more granules, basically releases some granules. So this is a good distinction. And another side concept to know is to know about the histamine or allergic reaction. So mast cells are basically release the mediators due to allergy. but we have to understand how does that happen. So when you have a first exposure to anything, so for example, simple example we can just make it up, is if we are allergic to peanut butter, and the first time you lick a peanut butter, your antigen that came from outside and the antibody, they will react and bind to the IgE receptors on the mast cells, and that will just give it a memory saying, okay, this is peanut butter. The second time you lick another peanut butter, a month later or a year later, the same antigen will go and bind to the IgE that's already present with the memory, and they will release mediators such as histamine that will activate phospholipase. The phospholipase will release leukotrienes, and that is how you get this puffy face. So first exposure, like we said, allergen causes production of IgE, which is bound to mast cells. So here you have antigen, here you have IgE. Once they bind and activate the cycle inside, here you can see in step 4, these granules start releasing histamine, heparin, proteoglycans, extracellular fluid. You also have phospholipids that activate phospholipids that release leukotrienes. So second exposure, the antigen binds to IgE, triggers release of all of these mediators, and that is how you get an anaphylactic shock. And lastly, just to memorize something, memorize this list of what histamine mast cells release. And that should be it. So once again, to recap our connective tissue, we went through connective tissue components, connective tissue function, the origin of connective tissue, what are the connective tissue cells, what are the monocyte cells, the connective tissue fibers, how they make up the collagen fibers, the collagen types, what collagen is found in the oral cavity, which we really care about as dentists, what are the connective tissues that formed using all of those cells, fibers, ground substance. Then we talk about the fat, white, what one, and bat balls, so a lot brown, has a small pockets of fat, usually found in babies. And then we did this quick chart that you can study to know all the cells, their origin, shape, and function. And finally, I will just go through a small quiz about histology slides. So here you can read this first question 1. So question 1, this is a colon, and you can see we have this epithelial, we have some kind of connective tissue going on. And number 1 says, identify the layer of connective tissue that is marked by the yellow stars. So it's pretty loose, not a lot of cells going on in there. So more than likely, this is the lamina propria. Lamina propria is the first one. Then you have identify the cells indicated by the blue arrows, which are inside the lamina propria. So what would these cells be in our lamina propria? So these are the fibroblast, like we said earlier. Fibroblast because it's pore stained and not a lot going on. So you have not a lot of collagen fibers in between. You just have these fat oval cells. Some are active, some are not. So you have your fibrocytes and fibroblast in there. The next one we have a section of the lip, and they just blew it up here. So number 3, identify these round, clear cells, nothing inside them. And that usually is easy because it's adipocyte, because adipocytes need all of the cell space to store fat. and basically all the nucleus and all the organelles are pushed to the outside, as you can see. So these are basically the organelles that are pushed to the side, and then in the middle you have most of the fat that is part of that. Okay, we go to the next one. Here you have the mesentery, and you can see we have a lot of lines, we have some cells, a lot of maybe collagen fibers or some type of fiber. And so what type of cell is in the middle? What type of stain and what is involved? A few clues are where is it, what type of dissection is this? So these are your mast cells because of all those granules that are inside these cells. Like you can see here, you have so many granules on these cells. So the most granules in a cell is usually mast cell. Nothing else has that many granules. And what does it secrete? It can secrete any of these mediators, like we said, for allergy, for histamine, heparins, cytokines, for vasodilation. Then we have number 5. What are the likely stained fibers that we can barely see in here? And those are your collagen fibers. Then we have some type of cell that is way in the back, very pale, no stain to it, and that is once again your fibroblast or fibrocyte. So it depends which one you're looking at. If it's skinny, it's fibrocyte. If it's fat, not a lot of staining, it's a fibroblast. As you can see, going back to the first image, these cells do look darker relatively. Like we said, they are fibroblasts. They're pretty well stained, but here, relative to the mast cells, our fibroblast cells are very pale in staining. So that is your clue here. Number 7, what is the more prominent dark stain fibers? So if your light stain is your collagen fiber, your stronger one is your elastic fiber. And if you want to review, we can go back to the chart of our fibers real quick. So here are your fibers. So you have collagen, pretty big. You have reticular, you have elastic. Okay. So number 8, is mesentery an example of loose, dense irregular, or dense regular? And that depends on, maybe we said less cells, more cells, or the type of collagen involved. And this would be our loose connective tissue. Not a lot of cells involved, or more cells actually involved, and that's why it's loose, but not a lot of more cells, but loose collagen, loose fibers. Here is a section of a tendon, and they just blew this up here. And you can see, first I see is pretty straight lines, pretty parallel fibers. These nuclei or these cells are pretty flat. So is this example of loose, dense, regular, or dense, irregular? And this one mostly everyone would say is a dense regular due to the cells and pretty nice evenness and parallelness. And then lastly, the last one, once again, looking at the other one we just did earlier, this is thick skin. This one and this one. The top one is pretty clean and has nice lines on it, whereas the bottom one, they're squiggly, they're messy, they're all over the place. So we can tell this one would be not loose, not dense, regular. This would be dense, irregular. Okay, so that was our quick review how to look at different type of connective tissues, what makes them up, what are the cells, how to look at the fibers, what type of fibers, and what type of staining is involved in our three type of connective tissue. So only thing you have to worry about is three connective tissues: loose, and then dense, irregular, and regular. And basically just know what are the cells, what are the fibers, what about collagen and staining, and those kind of principles that we covered in the beginning of this video. Thank you so much. Hope to see you next time.